X-ray equipment. X-ray technology plays a crucial role in modern medical imaging, allowing for the non-invasive examination of internal structure, from detecting fractures to diagnosing lung infections. X-ray equipment is an indispensable tool in healthcare. However, while its benefits are significant, proper safety measures must be implemented to protect patients and healthcare professionals from unnecessary radiant explore. Components of X-ray equipment. X-ray machines consist of several key components. X-ray tube, the heart of the equipment where energy electrons collide with a metal target to produce X-rays. Collimator controls the size and strength of the X-ray beam, reducing unnecessary exposure. Detector imaging receptor captures the X-rays passing through the body to create an imaging.
Ultrasound is an examination technique that allows images of the interior of the body to be seen using ultrasound. When this ultrasound hits the various tissues of the body, they produce an echo that is translated into images. Its most common use is during pregnancy, although it's also used to be organs such as the heart, kidneys, and liver, amongst others. What does it involve? Ultrasound is an examination method that obtains images of the interior of the body using ultrasound. With this ultrasound hit the various tissues of the body, they produce an echo that is translated into images. It is a comfortable, safe, and expensive technique for the patient. It is a test that allows instant observation of tissue and intestinal movements, internal organs, and circulating blood. What is it used for? It can diagnose a wide range of situations. The most welcome is for monitoring pregnancy, but it is used in all medical specialties. However, ultrasound is not used for observing body structures that contain bones or air.
Bone densitometry, also known as DEXA or DXA, is a test that uses low-dose X-ray to measure bone mineral density. It helps evaluate the effectiveness of treatment for osteoporosis and other diseases that cause bone loss. How is performed? The test requires no special preparation, is painless, and has no side effects. The patient lies on the table while an X-ray generation slowly passes over the area to examine, usually the hip or spine. The test lasts approximately 15 to 30 minutes, and the patient can resume normal activities immediately afterward.
The panoramic dental X-ray equipment is a diagnostic device, orthopan tomograph, that is used to capture 2D image of house, teeth, TMJ, and sinuses. It is essential for evaluation dental pathologies. It, its components are an X-ray tube, a digital sensor, a patient support system, and a control panel. Modern models are equipment with touchscreens. During operation, the patient is positioned to bite a gate and the rotating arm is synchronized to emit radiation. This sensor is exposed to create an image. Cave customers are broad coverage and low radiation. 4 and 7 microsieverts. Applications are identified impacted six and planning implants. Safety measures are lead approach and non-abrasive cleaning. Portable units are battery powered.
Generalities of tomography. Tomography is a medical imaging technique that allows visualization of scenes or sections of human's body in different planes. Here is a medical general overview. The word tomography comes from the Greek tomos, cut and grapos representation. It refers to obtaining imaging of body sections allows internal structures to be section window surgery. 1. Types of tomography. Computer tomography (CT) uses X-rays and computer systems to obtain detailed axial scenes to imaging of the body. It is of the most common types. Positron emission tomography. PET, a functional technique that detects metabolic activity in tissues, is used in oncology and neurology. Single photon emission computed tomography aspect similar to PET but uses different types of radioisotopes. Optical tomography uses infrared light to obtain imaging of tissues, often used in ophthalmology. Magnetic resonance imaging (MRI), although not always called tomography, some MRI modalities produce similar section imaging using magnetic field and radio waves. Advantages: precise visualization of internal organs and structures, early detection of disease, guesses for medical and surgical procedures. Application: diagnosis of tumors, infection, trauma, cardiovascular, and neurologic diseases. Procedural evolution.
Magnetic resonance imaging is an advanced device that uses a magnetic field and radio waves to create images of organs and tissues inside the body. Unlike other imaging devices that use radiation, magnetic resonance imaging is non-invasive and does not expose patients to initial radiation. The main parts of magnetic resonance imaging system include: 1. Magnet generates the magnetic field needed for magnetic resonance imaging. This can be a permanent magnet or an electromagnetic coils. Device that transmits and receives radio signals. There are different types of coils, such as sulfur coils and body coils. 3. Control cells allow the operator to adjust the scan parameters and coordinate the equipment's functions. 4. Computer process the received signal and transform the data into images that radiologists can interpret. 5. Examining tape, where the paint is positioned during the scan. The table can move in and out the magnet. 6. Display screen. Display the generated image and allow the attending physician to analyze them in real time. 7. Imaging software. Program that assist in viewing, analyzing, and storing the images obtained. These components work together to provide detailed and accurate images of the interior of the body.
C-arming equipment. C-arming equipment is a type of medical imaging system that uses X-rays to obtain real-time images of the human body. This equipment is especially useful in surgical and interventional procedures, as it allows doctors to visualize the area of interest with precision. Components of the equipment. X-ray generator produces the X-ray used to obtain images. X-ray tube emits X-rays towards the patients. X-ray detector captures X-rays that pass through the patient's body and convert them into electrical signals. C. Armington C. Sapet design allows for greater flexibility and access to the patient during procedures. Advantages of the equipment. Real-time imaging allows doctors to visualize the area of interest in real time, facilitating decision making during procedures. Higher precision. The quality of images obtained with C-arming X-ray equipment is high, allowing for greater precision in diagnosis and treatment. Flexibility. Tense sampled design allows for greater flexibility and access to the patient during procedures. Application of the equipment. Suggeries C-arming X-ray equipment. Committing used in surgical procedures such as orthopedic surgeries and vascular surgery. Interventional procedures. Used in interventional procedures such as stent, placenta, and tumor embolization. Diagnostic. Also used to obtain high-quality diagnostic images of various parts of the body. Safety and protection. Radical protection. Protect radiolocal protection measures should be taken to minimize exposure to X-rays for both patient and medical personnel. Equipment maintained regular maintenance is necessary to use the equipment functionally correctly and safely.